Good morning, students. So today we are going to see the concepts of vibration, okay, or different vibration systems which are available for the dynamic analysis. Okay. So if you take vibration, so vibration can be classified into two types, that is free vibration and forced vibration. Okay. So it can be classified into free vibration and forced vibration. And there is another concept, that is damped free vibration and damped forced vibration. Okay, in damped itself we have free vibration and forced vibration. Okay, right. There is free vibration, forced vibration, damped free vibration, and damped forced vibration. Let us understand the concept of free vibration first. Okay, so free vibration, to explain this concept, I will just draw a pendulum so that you can understand what is free vibration and forced vibration. Okay, so now I have a pendulum which is suspended from the fixed support. Okay, so to cause the free vibration, I have to give some initial displacement. Okay, it's not like I'm applying a force. I'm going to apply an initial displacement, in the sense I'll be pulling this pendulum to a new position. Okay, I'm just pulling this pendulum from this position to this position. Okay, and I'm just going to leave that pendulum. So I will be leaving the pendulum so that this pendulum will be going to and fro, right? So it means what? I'm going to give an initial displacement, say x. Okay, then I'll be leaving it so that the pendulum will go to and fro and causes a vibration. So that vibration is called free vibration because of initial displacement which was given by me, right? So the same thing, how to apply forced vibration. Let me take the same pendulum. Okay. So now what I'm going to do is I'm going to apply a force here, say F. Okay, it means I'm going to hit. Okay, I'm going to hit this pendulum with some force. Okay, because of this hitting effect, the pendulum will start oscillating to and fro. Okay, because of this force. Okay, because of this force, I'm having a to and fro oscillation or motion, that is called forced vibration. So here I'm applying an initial displacement so that vibration starts. So that's why it is called free vibration. Here I'm applying a force F at this point so that the pendulum starts vibrating. Okay, this is forced vibration. Okay, so now what is damped free vibration and damped forced vibration? So first you should understand what do you mean by damping. So damping means what? Arresting the vibration with some external device is called damping. Okay, or the damping can happen within the structure itself. Okay, because of its own weight. Okay, so if I do this vibration, okay, if there is no resistance, obviously this vibration is not going to stop. But actually speaking, in real-time conditions, there is some possibility for air friction. Okay, some external force may happen. Because of that, the oscillation will stop slowly. Okay, that's why it's called damping effect, right? Okay, so to understand the damping concept in real-time condition, I'll explain you using a door. Okay, so if you take AC door, okay, AC door, obviously AC room door, you can find a dashboard which is placed over the top of the door. Why? Because the door has to get closed once someone open the door. Okay, so if there is no damper, what happens? People will just open and they will go for some work. They'll forget that they didn't close the door. Because of that, AC will be going out. Okay, air conditioning will go out. Obviously, the power consumption will be more. So that's why if you take a AC room, there will be a door which is should be having a dashboard over its top. Okay, over its top to close the door automatically. Okay, so that dashboard is a damper. Okay, the dashboard is a damper which will be having some viscous liquid in it so that smoothly that door will close. Okay, let me draw the door in the top view. Let's say this is the door. Okay, so this door is just open. Okay, this door is open and it is left. Okay, so automatically this door will go and stop here. Okay, right. So damping will happen because of the damper which is placed over its top, right? Okay. So in damping itself, we have different types of damping system. So what are the different types? So if we take damping, we have critical damp system, under damp system, and over damped system. Okay. So we have three types of damping system. So how to understand this concept means, for example, if we take the critical damp system, okay, critical damp system, in that case, if I open this door, okay, and leave it, this door has to get closed automatically, and it should stop exactly at this door frame. Okay, it should not go out of this door frame. It has to directly come slowly and steadily, and it should reach here. Okay, so that is critically damped system. We are taking this as the benchmark. Okay, that is critically damped system. So what do you mean by under damped system and over damped system? Suppose the damper is not performing well, the function of the damper is not performing well. Because of that, what happens? The door will go and close, bang here. Okay, this door will go and bang here, and it will move to and fro. Okay, it will move to and fro because of the inefficient damper which is or dashboard which is applied. This door will go fast and it will go to and fro. Okay, so that's why it is called under damped. The damping effect is very less. That's why it is called under damped system. And if you take over damped system, the damping effect of this dashboard will be very high, such that the closing will be very slow compared to your critical damp system. It will go very slow and it will just close here. Okay, that's why it is called over damp. Okay, because of the high damping effect, door is slowly closed. Okay, that's why it is over damped system, right? So if I draw the amplitude, okay, versus time, right? Amplitude versus time. Obviously, the vibration in case of critically damped system, it will slowly reduce the vibration and it reaches one particular point. Okay, uniformly it reaches, right? So if you take over damped system, damping effect is very high, so that it will take more time to close the door. Okay, so the same point, it is starting here. Obviously it will consume much time to close. Okay, that is over damped system. And if you take under damped system, it will be closing very fast and the motion will be to and fro. Because of that, this amplitude will be varying like this, and it slowly it will stops the vibration. Okay, this is under damped. So this is over damped system, under damped system, and this one is the critical damped system. Okay, these are the different damping system which is available in dynamic analysis. Okay, a quick recap. So here we have seen the different types of vibration. It is free vibration, forced vibration, and damped free vibration, damped forced vibration. And here for free vibration, initial displacement will be given. Because of that, there will be a oscillation will be happening. That is vibration will be happening. Okay, and here initial force is given. Because of that, vibration happens. That is forced vibration. This forced vibration will be in the kind of harmonic motion, okay, harmonic oscillation. Because of that, generally this force is represented in terms of sine or cos. Okay, F naught sine omega t or F naught cos omega t because of its harmonic nature. Okay, and in case of damping system, there are three types of damping system: critical damped system, under damped system, and over damped system. And we have seen the corresponding picture with the example of a door stopper. That is with dashboard, how the closing effect is happening. Okay, for three damping systems. Okay, hope you enjoyed the video. Give your comments in the comment section so to improve. Okay, thank you.